Hello, global supply chainers, and welcome to the wrap-up event in SC0x Supply Chain Analytics. My name is Ahmad Hemmati, and today with me is Dr. Chris Kaplis. So today we're gonna wrap up the SC0x, and we're gonna talk about what we learned in this course and how we want to use these techniques that we learn in SC0x in the next courses that we offer for supply chain. And after that, we're going to talk about the projects that we have done using these techniques. But before passing the stage to you, Chris, I'm going to share with the learners some stats. In this round of the course, we had 27,000 of students, where 1,500 of them were verified students. The median age was 29, and they were from 172 countries. Where in India had the most learners, 20%.
Wow.
Then it was the first time.
Yeah.
That India passed US. So US with 19% and Brazil with 4%. So Chris, stage is yours.
Okay. Excellent. Thanks, Ahmad. So what I want to do is 4 quick things here. I'm going to talk about what I think you've learned, hopefully what you've learned during the course, and how you'll use these within the course, and then how you might use these in your career. I'll give some examples, and Ahmad will give an example as well. And then we'll do a breakout. And in the breakout, what I'm going to ask you is to think about a problem or a challenge that you've had in your job, in your career, and how one of these tools or multiple of these tools you think might be able to be used to help solve that. So I'll give you more details on that, but you can start thinking about that now. So this is the second run of SC0x. And the first runs, if any of you have taken any first run courses, they're always a little rough because we never know how deep to go or how broad to go. So what you guys just finished or are just finishing, because they haven't taken the final yet, right?
We just finished it right now.
Okay. This went much more focused. I'm much happier with this course. Ahmad's done great things shaping it, and it's been turned, I think, into a very valuable course. And so the things that I think you should have learned, I put them into 4 big buckets. The first one is one we've never talked about, and that is that hopefully you've gained or recovered your mathematical dexterity. And so what I mean by that is most of the things we do later on, you use basic mathematical skills that you might have been taught back when you were in grade school or high school or maybe first years of college, but you've forgotten. And so just getting that dexterity back, it's kind of like doing calisthenics and getting back in shape. So the whole idea of using functions you should be really familiar with that now because they're everywhere. Even if you don't see them immediately, they're there. And so mathematical functions, just mathematical prowess, being able to handle these things, simple algebra. A lot of people need to brush that rust off. Also, we introduce you to the idea of approximations and approximating things, which is exceptionally valuable. If you take nothing else out of this, the skill of being able to approximate to orders of magnitude is something that will serve you very well over your career, just having that in your back pocket. But the 3 big things we did, we taught you 3 classes of tools. And these are tools you now have in your tool belt, and therefore you should be sick of me saying this, prescriptive, descriptive, and predictive types of analysis. So we started with optimization, and we started with the very simplest, unconstrained, minimizing or maximizing a function with no constraints. And min-max, first order conditions with second order conditions for proof. And these are prescriptive models. They will tell you a solution, an answer that is the best, minimum cost, maximum profit, whatever that is. And then we moved into constrained with the linear programming, mixed integer linear programming, integer programming, and a little bit of nonlinear programming. But the real workhorses here are linear programming, where you have minimize or maximize a function subject to some constraints, and everything's a linear function, to mixed integer linear programs. You will use these throughout your career. You might not know you're using them, but you're using them, and hopefully you'll have an appreciation for those. So those were the optimization of prescriptive tools. Then we taught you a whole bunch of descriptive tools, and this is when we introduced probability and statistics, because what you learned here is to take data and how to characterize it. And with the 2 big things we talked about, central tendency and dispersion or spread, and that helps you understand the shape of that distribution, whether it's demand, transit time, anything that has lots of data points, you can now shape this as a distribution. And then we introduced some theoretical distributions that your empirical or your actually observed distributions can map to. And the two big ones that we're going to use over and over again are normal and Poisson. With a normal distribution, right, that bell curve with a central tendency, with the mean, the median, the mode, the same value, and it's symmetric around that. And so you have a mean and a standard deviation, and we'll use normal distributions a lot throughout the courses and throughout your career. Poisson's a little bit different in that it can't take negative values. It's a discrete distribution, and so it predicts things on a discrete, and it has that nice curve or tail to the right, right? And so that's usually for lower valued distributions, and it has one parameter, lambda, which is the mean and the standard and the variability. So these two distributions are the workhorses. There are many, many, many other ones that you'll use if you go deeper, but these are the two workhorses you'll see the most in inventory and the other things in supply chain. Finally, we did regression and simulation. I lumped those together because these are both predictive tools. You use regression to form a relationship between a dependent variable, a y, and a bunch of independent variables. So y is a function of x, another function that we talked about, where the dependent variable, say it's demand, it's a function of the number of people in an area, their demand, all these other things. And so you create a relationship based off that, and you're looking at correlations, not causation. Hopefully we made that point. But what you're really doing is saying this dependent variable depends on these other independent variables. And then we introduced simulation, and I lump them together because they're used in the same way. Both regression and simulation will never tell you an answer. They won't say you need to do 6. That's what optimization is for. What it will tell you is if you do a certain thing, here's what we think will happen. So if you create a predictive model, a regression model of the cost of an apartment based on the square footage, if I come in and I want to know the cost of an 800 square foot or 1,000 square foot apartment, I can find that cost because I'm now able to predict. Same thing with forecasting. Simulation does the same thing. If I have a policy and I see how well it performs, so it rates, ranks, or evaluates, it doesn't prescribe a solution. So we touched our toe in the water for simulation, and I showed simple Monte Carlo simulation in a spreadsheet, and then we showed an extended example using sophisticated software for discrete event simulation. Both have a role, and you have to decide which tool, which way you want to go, but the real key difference there is how you advance the time, right? For what I showed in the spreadsheet, time advanced every day. I did a simple simulation based on the demand, inventory, and sales. For the discrete event simulation we did for the airport kiosk, that was every event, whether a passenger came in, or they left, they were serviced by the kiosk. So these are the key differences in the types of simulation that you use, and they each have a role. One is much simpler and easier to implement. The discrete event simulation, you can do it in Excel or a spreadsheet, but boy, it's hard. You really need to use sophisticated software there. So these are the 4 big buckets: mathematical dexterity, optimization, probability and statistics, regression and simulation. So these are now in your tool belt.
Great. So yeah,
go ahead.
So we have the toolbox. So we have the techniques, but where in supply chain we can actually use this?
That's a great question, Amat.
Yeah.
Yeah, no, that's great. So we teach them for a reason. We just don't teach them to teach them because there are a bunch of other things that people wanted to add in, and we decided not to because we only wanted to teach the things that you're going to use mainly in the rest of the courses in SC0x. So let me just quickly run down, because the next course you guys should take is SC1x, which starts this week or next week, very, very quickly. It gets long.
SC1x just to start.
To start at week 0?
Week 0 just to start.
So you have time, you can take a week off and hit it next week. But we do 3 big things in SC1x, and that's where we look at forecasting of demand, managing inventory, and planning transportation. These are the big 3 in supply chain and logistics. So you'll use all these tools that we taught you in these 3 big buckets. For forecasting demand, you'll use regression because demand many times is treated as a dependent, right? My demand depends on these other things. So we'll use regression a lot there. You'll use your statistics to measure the accuracy of your forecast, how well you can look at the accuracy and the bias of that forecast. You'll use functions all the time. That mathematical dexterity will help you a lot when you get into exponential smoothing because it's really bookkeeping. but if you don't understand how a function works, then you can get lost. So we'll use all those tools for forecasting. In inventory, it's all about optimization. Two most common inventory models are something called economic order quantity and news vendor, single period. And each of them are optimization models. EOQ, or economic order quantity, does the trade-off between fixed and variable costs. And you're going to see this in every inventory system. The single period problem makes a trade-off between cost of having too much inventory and cost of having too little, excess and shortage. And so each of these are optimization problems, and you use optimization to come up with an answer because you're making a trade-off. That's the whole thing with SC0x. It's all about the trade-offs. Do I have increased my service versus cost? Having too much and too little? Fixed versus variable? Optimization is used to make those trade-offs to come up with the optimal or best solution in every time. Also for inventory, you're going to deal with a lot of uncertainty because demand is uncertain. So you're going to dive into normal distribution more. You need to know what is the probability that I will stock out if I have a certain amount of inventory. So you get a lot of use of the probability work that we did before. And then for transportation, it's similar to inventory. It's a lot of optimization to make sure mode selection. You're making trade-offs. Should I do the faster mode? Should I send things by truck that costs a certain amount, or by rail, which costs a different amount? And you're making, again, trade-offs between time and money. And you'll use optimization for that, as well as probability and statistics when you have uncertainty, because your demand will be uncertain and your transit time is uncertain. So how I combine those together is a little tricky, but we'll show you how to do that. And you'll be relying on the probability tools that we taught you in SC0x. In SC2x, we'll dive into supply chain design, and you'll use a ton of the mixed integer linear programs. We'll use them for network design, for facility location, production planning, as well as aggregate planning. All of these different tools use mixed integer linear programs. In my opinion, it's the most widely used tool in supply chain because it lets you make an optimal decision based on a lot of inputs. And you'll see it no matter where you go in transportation. You'll also, in supply chain. You'll also see it in procurement because more and more companies are using optimization-based models for procurement. So mixed integer linear programs, that's a big tool you'll use a lot going throughout the course. SC3x, you'll use some simulation, both for processes, because we talk about queuing a little bit more. We talk about that process, but also we introduce something called system dynamics, how different systems interact. And we'll do some simple simulations to show how behavior can change over time. Also in SC3x, we'll do a lot of optimization probability using risk contracts. And so that's the whole idea. If I'm a vendor to a company and I'm selling them product, I might be able to form a risk contract that increases the total profit for both of us by sharing some of the risks, some of the costs. And essentially, it's building on some of the models you developed in SC1x, as well as the tools that you learned in SC0x. And then finally, in SC4x, the last course, Systems and Technology, that's all about data manipulation, because we move from these small problems to how do you deal with massive amounts of data. So the whole data manipulation, everything you learned in 0x about that mathematical dexterity, it's through the roof now because you're dealing with millions of records. How do you handle that? And we introduce relational databases and things like that. And also in SC4x, we kind of add on to your analytical tool belt by teaching you some machine learning. And this is something that complements all the basic analytics that you just learned. So you see, throughout the remaining 4 courses, you will rely on the models and methods that you used in SC0x. So now I want to turn to the last one.
The projects. Okay. Yeah. Before that, I got a question from Asma, which is asking about what's the best use of SAS, Ample, or Excel. So if you're asking which software is better, for different techniques or different problems, I would say you can use Excel for most of the the topics that we have covered, but for optimization part, specifically for mixed integer programming, I do recommend to use Ample or SAS because they're more robust and they are kind of designed to do those stuff. So But Excel is really good for visualization. You can, plot, the data. It's really good for regression, and yeah, you can use Excel for simulation, but not for larger scale, not for discrete event simulation. But
I agree with everything you're saying. I think Spreadsheets, Excel specifically, is really good for prototyping. So if you get something really quick, you do some quick analysis on it. Spreadsheets are awesome. But if you're going to do something and you test something out, I'll do quick optimization models in it just because I find it easier to visualize it. But as soon as it gets beyond a certain scale, or if it's something that we're going to be using more than once, then move into another system. Back when I was doing coding, I'd go into SC0x, which is another system. But Ample and SAS are great tools. For regression, I'm starting to use more and more SAS. I used to use it back in the 80s, but then I went away and started using SPSS. But the beautiful thing, don't hook into one brand, because what we tried to do is teach you the fundamentals. You hopefully should be able to jump between tools, because we have no idea what the next tool is going to come out. But if you understand the basics behind it, you should be fine. And your company might dictate what tool you use because they'll have the license fee. There's some that they dictate the type of tool you need to use.
Yeah, I don't want to tell that's not that's old, but
yeah,
at the time you are using the SAS, it was mainly a
mainframe.
Mainframe for statistical.
Absolutely.
Yeah. But right now, SAS is very general purpose software, which is doing
a lot has changed since the 80s. I had hair when I used to use SAS. Yeah, and the big manuals, the big thick manuals you have to use. Yeah, things have changed.
Yeah. Okay. Maybe it's time to go to
real
projects that you have done.
All right. Yeah. Yeah. So essentially, I broke it down. There's 3 quick examples, and these are examples that I've done either in consulting or with students here for companies. So the first one is with a company called C.H. Robinson. So hopefully you guys have heard of C.H. Robinson. They're a global company. They're the U.S., if not the world's largest brokerage company. They're really a transportation management. And so they actually started in managing agriculture movements, vegetables and fruit, but now they're a massive company. And one thing they do is manage transportation for companies, kind of as a 3PL. And so we've had a number of projects with them, and the question, because there's always an underlying fundamental question, and their question is, what are the things that a shipper, someone who's buying transportation, can do to improve their rates? So in other words, what are the things that impact the transportation rates that the transportation carriers, the trucking companies, charge? So if you get this question, you're thinking, okay, what influences or what are the correlations? You should immediately start thinking of regression or some kind of statistical model. And so what we've done for them is we've developed a series of models over different projects that we've run to try to see, okay, the dependent variable is the rate, the transportation rate that the carrier charges. What drives that? What influences that? Where are the correlations? And so you can think of developing a series of models where you look at the distance, some of the other characteristics of the product itself, the geographies, and we found things such as the amount of lead time you provide influences it. And it's not always linear, but what we did here is develop a series of regression, ordinary least square regression, as well as some models that we haven't talked about that build on that, things like binary logit models, which are essentially regression models where instead of your y or dependent variable being a continuous variable, it's binary, it's 1 or 0, right? And so we develop models that say what influence, say, for example, the having on-time delivery. Are there certain characteristics? And that on-time delivery is my dependent variable, and it's either yes or no. So you have a binary, and then you have all these dependent variables or independent variables that influence that, and you try to find the correlations. So we've done a lot of these kind of models for C.H. Robinson where we use all the statistical tools. Another project we've done recently is with a company called Starbucks, and you should probably know Starbucks. If you're anywhere in the world right now, there's probably one within a mile of where you are. But they're a big coffee house, and they are moving away, not moving away, but moving towards being more than just a place to get coffee. They're bringing in fresh food. And so the problem that we worked on is how can a company provide fresh food on a daily basis at a cost-effective manner to a set of very small stores in an urban environment. And so they had different options. You could have it coming from the kitchen that makes the fresh fruit each day to the distribution center that then gets married with the other products that gets delivered to the stores. Or you could have it as a separate channel, or you might have something blended like that. So you have all these different options of how you deliver to the stores. And what we did there is we developed what's known as a total cost model. And that's simply looking at all the cost elements that affect the cost of getting product from A, the kitchen, to B, each of the stores. Now, to estimate some of that, we had to do some approximations of local routing. And since this was a strategic model, you're not going to actually find the exact route that you would deliver between each store because it would change each day. So we used continuous approximation, similar to what you learned earlier in the course. And so we assumed the routing cost based on the density of the stores and the area within each city. And so we developed a model where you could determine, okay, if I could get the price down below a certain amount, I would run the distribution through the DC, or I'd go directly from the store. And we help them determine where the breakpoints, when the demand for the fresh fruit hits a certain point, should they shift the distribution method, going through the DC or coming straight from the kitchen, and it's those kind of related questions. The tools we used were just analytical cost models, but also that approximation method that we taught you before, to approximate something that you can't solve exactly. Last one is a project we did with Walmart about a year or two ago, and so it's also a replenishment question, and their question was, how can we deliver product of 3 different temperature zones efficiently to all of our stores? Because they have a series of stores that are smaller footprint, these neighborhood markets, and they sell frozen goods, refrigerated goods, produce which is a little colder than ambient, but not frozen, there's a different temperature zone, and then ambient or room temperature goods. And they have these trucks that are called multi-compartment or 3 temperature zone trucks, where you have an ambient or refrigerated and a frozen zone to it, or they can have trucks that are all of 1 zone. And the question is, which should they use where, and how should they plan on using those? So as soon as you frame a question like that, immediately what should pop up is, well, we want to know how to do something, so it's an optimization problem. There is probably a best way to do it. And so we developed a mixed interlinear program to help determine which types of vehicles to allocate to which types of routes and of what quantities. And you can see it's subject to making sure the stores get a sufficient amount of each of the temperature zone materials, subject to their demand, and also to minimize the cost. And so that was where we used a large-scale mixed interlinear program. So these 3 projects use different models, and it's all based off of what question you're trying to answer, and then think about, okay, what model, what approach should I use for that? Is this asking for a prescriptive, a descriptive, or predictive type model? So you want to talk about your recent one?
Okay, so we just finished one project for one of the biggest multinational manufacturer here in US. So together with our master students in supply chain management. So what the company asked us was to find a steady flow for their daily transportation from the plant to distribution center. And what we did, we actually used several techniques that we had in SC0x. We used the summary statistics, so to find the eligible products to send through the steady flow. And then we use the optimization techniques to figure out how many trucks we need and how to build the vehicles. And then we use simulation part to figure out what will happen in the future for the what type of uncertainty to simulate the uncertainty that we may face in the future and to deal with them. So if the model is robust in terms of facing with the uncertainties or not. So yeah, basically we covered different part of the SC0x in that project. So
that's a really good point, because a lot of these problems, they're not just, they don't come and say, oh, I'm a hypothesis testing problem. That you're going to use a little bit of everything. Especially the funny thing about hypothesis testing and all the statistical tests, you don't use them explicitly, you use them implicitly. So when you run a regression, you're using them. You're looking at t-stats. So you're looking at the p-values. Hopefully you have a good grounding on the p-values. You'll see these all the time, but they're kind of part of other analysis. But you'll use this smorgasbord, if you will. It's a Norwegian word, right? Smorgasbord of these different options, this portfolio of different tools. And you never know which one you're going to use, and that's why we teach them all.
Great.
All right.
So we have the breakout rooms today. So
yeah. So here's what I'd like you to answer: discuss a challenge or a problem that you faced in work, and talk about it with each other. And what would be fun is if someone presents a challenge, the other people say, "Oh, I'd use regression for that," and maybe you want to consider that. Then at the end, we'll give them what, Arthur? 10 minutes? 15 minutes?
You have to report that.
Yeah. So 15 minutes. We'll send a bell and everything. Come in, send us in chat what your problem was and that, and we'll talk about it. Also, if you have any other questions that for Amat or myself, or even for Arthur, let us know, and we'll answer those as well.
great. So please join the breakout rooms, and then we will hear back.
Great.